Hi everyone, welcome to Algebra 2 Common Core. My name is Miss Anfini. I'm one of the teachers that will be making the videos this year. Our first lesson will be on adding and subtracting polynomials. Before we can actually get into doing adding and subtracting, we're going to need to review some vocabulary. Let's start with the word variable. Variable is simply a letter or a symbol that is used to represent a number. So we have a few examples here: x, y, n squared. These are all examples of variables. A coefficient is a number in front of a variable. So we've got example 3x squared. 3 is called the coefficient and x squared is the variable. We're going to skip over polynomial for a minute and we're going to go straight to terms. So terms are separated by plus or minus signs, or addition and subtraction signs. So here is a plus sign and I have a 5x and a 5 on opposite sides. That means I have two terms. I have a plus and a minus sign here and I have three things in between, therefore I have three terms. A monomial is something that is one term, binomial is two terms, trinomial is three terms. Think of the prefix. Trinomial is like tricycle, there's three wheels on a tricycle. Binomial, bicycle, there's two wheels on a bicycle. So all binomials are going to have two terms, all trinomials are going to have three terms, and a monomial has one. A polynomial includes monomials, binomials, trinomials. Basically, it's an algebraic expression with one or more terms. Your teacher will define this a little bit more in detail in class. Alright, now let's move on to degree. So, the degree of a monomial is the sum of its exponents. So let's look at these four monomial examples. What is the exponent here? If there's nothing written, what do you think it should be? You should be saying 1. So if there's a 1 there, the degree is 1. It's the sum of the exponents of the variables. Okay, look at the example 3x to the third. The sum of all of the exponents is just 3. So therefore, the degree would be 3. How about example 3? We have 4x squared z to the third. There's two different variables here, x and z, and the sum of the exponents, 2 plus 3, is 5. And last but not least is 27. This one's a little bit tricky. There is a variable there. It's just not written. That variable would be x to the 0. From Algebra 1, this should ring a bell. X to the 0 is the same thing as saying 1. So really, we're saying 27 times 1, which makes 27. So the degree in this case would be 0. Next, the degree of a polynomial is the degree of the term with the greatest degree. So let's look here. We've got a polynomial x plus 2. It's a binomial. It has two terms. What is the highest degree? The highest degree would be x to the first. So therefore, the degree is 1. Let's look at example 2. We have a trinomial here, 2x squared minus 10x plus 15. The highest degree is an x squared, therefore 2 would be the degree. Okay, we have another polynomial, 3x to the fourth minus 7x squared plus 13x minus 5. The term with the greatest degree is a 3x to the fourth, and the degree of that is just 4. And last but not least, 10. This one's just like the example before. 10 is the same thing as writing 10x to the 0. What's the degree there? You should be saying 0. Okay? Last vocabulary word. The leading coefficient of a polynomial is the coefficient of the term with the greatest degree. So in all of these four cases, they're the same as before. It's the coefficient of the greatest degree term. So here is my greatest degree. Here's my term with the greatest degree. All of them are right here. What is the coefficient of this term? You should be telling me 1. What is the coefficient of this term? You should be telling me 2. What is the coefficient of this term? You should be telling me 3. And what is the coefficient of this last term, 10x to the 0? You should be telling me 10. Okay, now I think we're ready to try some examples. Let's look at example number 1. let f of x equal this polynomial, and let g of x equal this polynomial. Part A wants us to find h of x, which will be the sum of those two polynomials. Usually when we find the sum, we want to put the highest degree first. So let's look around and try to find the highest degree. This here is a degree of 4, a 2, a 7, a 0, a 3, a 3, a 2. So the highest one would be negative 9x to the 7th. Don't forget to grab that sign that's in front. Now, can I add that with any x to the 7th on this side? No. So we're going to start by naming h of x to equal negative 9x to the 7th. That's going to go first. Now let's find the next highest degree power. Okay, so we looked at that and we have 7, we have 2, we have 4, 3, 2. I think 4 is the closest. And there's nothing to combine that with on this side. There's no other 4s. So we're just going to bring down that positive 17x to the 4th. The next power would be to the 3rd. So we're going to take this negative 2x to the 3rd and this positive 11x to the 3rd, and you're going to add them together. So if you have your calculator, take it out and put in negative 2 plus 11, and you're going to get 9. So we're going to write plus 9x to the 3rd. The next power would be squared. So we see over here that we have an 8x squared, and over here we have a negative 8x squared. You should be thinking, well, when I add a positive 8 and a negative 8, I get 0. So these two are going to cancel out to 0. Now the last terms that we want to talk about are just the numbers. So let's combine them. What do we have? We have a positive 4 on this side and a positive 12 on this side. When we add them, we get positive 16. So this, h of x, is my sum of g of x and f of x. Now part B is asking, what is the degree of h of x? Well, you have to look at the highest term, and the degree would be 7. And now the leading coefficient, we still have to look at this first leading term, and now we're going to look at the coefficient. The coefficient is the number in front, so we get negative 9. What I'd like you to do right now is pause the video, and please try example number 2. You may hit resume once your answer is complete. Okay, your answer for h of x should have been 3x to the 11th plus x to the 6th plus 4x to the 4th minus 9x minus 3 with a degree of 11 and a leading coefficient of 3. I got the 3x to the 11th because there were no other terms that had a power of 11 on the g of x side, so I just left that one. Same for the x to the 6th, there was nothing to combine with that. And same with the 4x to the 4th over here. The only things that I were able to combine was the negative 8x and the negative x. So it's like you're taking a negative 8 and adding a negative 1, and you get negative 9. And then here we have negative 20 and positive 17. When you add those together, you should get negative 3. The degree of h of x is 11 because it's the highest power. The leading coefficient is 3 because it's the coefficient of that leading power. Okay, I think we're ready for subtracting now. So just remember that when we're subtracting is the same thing as adding the opposite. Let's go ahead and fill that in. So remember, subtracting is the same thing as adding the opposite. So for example number 1, they want us to take these two polynomials, f of x and g of x, and they want us to subtract them to get h of x. So subtracting is the same thing, so we're going to take f of x and g of x as adding the opposite. Some of you may think of this as keep change change. So this positive 6x, well, the opposite of a positive 6x is a negative 6x. So negative 6x squared. The opposite of a negative 9 is a positive 9. And opposite of a positive 3 is a negative 3. Opposite of a negative 18 is a positive 18. So when we find polynomial h of x, we now add the opposite, and that's what we're doing. So let's find the highest power. When I look around here, I see that the highest power is 12x to the 3rd. And I'm going to add the opposite, so I'm going to add an 18x to the 3rd. So when I take 12 and 18 and add those together, I get 30. So 30x to the 3rd. The next power would be squared. So I have a negative 8x squared. and a negative 6x squared, and I'm going to add those. Negative 8 plus negative 6 is a negative 14, so I get negative 14x squared. The next term would be x, so I have a positive 5x and a positive 9x. I add those two together and I get a positive 14x. And last but not least, I'm going to take my numbers. So I have a positive 19 and a negative 3. I'm going to add those, and I'm going to get a positive 16. So that should be your polynomial. What is the degree? The degree would be the one that has the highest power. So the degree here is 3. And what is the coefficient of that power? The answer is 30. Okay. I'd like you to try example number 2. It's a little bit trickier because it says subtract f of x from g of x. That means g of x is going to go first, and then I'm going to add the opposite of f of x to it. Please pause the video until you've done this problem, and you may check your answer when you are finished. Okay, your answer for h of x should be as follows. Negative 5x to the fifth plus 10x to the third plus 6x squared minus 10. With a degree of 5 and a leading coefficient of negative 5. Here's the degree of 5, here's the leading coefficient of negative 5. So now let's talk about how I got this function h of x. So I took the opposite of f of x and I added it to g of x because subtracting is the same thing as adding the opposite. So I took all of these terms, the negative 4, the 8, 19, and negative 5, and I switched their signs. So the negative 4 became a positive 4, positive 8 became a negative 8, 19 became negative 19, negative 5 became positive 5. I found the highest power. The highest power is x to the fifth. So if you take negative 10x to the fifth and positive 5x to the fifth, you'll get negative 5x to the fifth. Now the x to the third comes, and there's only one x to the third term, so I just brought that down. And I took next the 4x squared and the 2x squared and added those, and I got 6x squared. And then I took my my positive 9 and my negative 19, added those, and I got negative 10. Okay, now I think we're ready for a few word problems. Example number 1. A rectangle has a length of x and a width of 5x to the third plus 4 minus x squared. So the first thing I like to do whenever we have a word problem is draw a picture. So that's why I left the space over here. Let's draw a picture. And let's put our length of x and our width of 5x to the third plus 4 minus x squared. Now, the question tells us for part A to find the perimeter of this rectangle as a polynomial in terms of x. That just means leave it with all the x's. Well, we know that the perimeter of a rectangle just means to add up all the sides. So if we know that this side is x, then this side must also be x. And if we know this side is this polynomial, then this side must also be the same. So 5x to the third plus 4 minus x squared. So add up all the sides to find the perimeter. What would the highest degree be? The highest degree is your 3's. So what's 5x to the third plus 5x to the third? You should be telling me 10x to the third. The next power would be our x squareds. So if I have a negative 1x squared plus another negative 1x squared, what's negative 1 plus negative 1? You should be telling me negative 2x squared. The next power would be x. So I have one x over here, another x over here. If I add x plus x, I should get a positive 2x. And last but not least, our numbers, what's 4 plus 4, should tell me 8. So this polynomial that I wrote out here is the perimeter of the rectangle as a polynomial in terms of x. So let's call that p of x. P for perimeter, and we'll call this the function p of x. So we want to find the perimeter now for part B of a rectangle when the length is 15. Well, it's set up here that the length is x. So basically I want to find p of 5. So everywhere I see an x, I want to plug in a 5 using parentheses. So 10, 5 to the third, minus 2, 5 squared, plus 2 times 5, plus 8. Now all you're going to do is put this whole thing into the calculator just the way you see it with parentheses and everything, and you'll find the perimeter when the length is 5. Please pause the video until you've done so. Okay, your final answer should be 1,218 units. Since we didn't give units, we should just say units. 1,218 would be my perimeter. The length were 5. Okay, examples 2 and 3 we'll leave for you to do for homework. This will be checked tomorrow when you come into class. There is just one quick correction that needs to be made. Example number 3, part A, where it says write a polynomial equation h of x to represent the total number of travelers. You need to specify, it needs to say the total number of travelers visiting Florida. Okay? So please complete these 2 problems and we'll see you in class tomorrow. Thanks. Have a good day.